Use the substitution method to find the simultaneous solution. Again, when using the substitution method, you want to choose a variable and equation where it's easy to solve for the variable. So when I'm looking at the first equation, I have a choice between solving for x or y. I would choose y because its coefficient is 1. You could look at the second equation and notice that the coefficient of x is 2 and the coefficient of y is -3. That might not be a good equation to choose to solve for one of the variables. So I'm going to go with the first equation and solve it for y. So if I do that, let me just write this over again. 4x plus y equals 5. And if we solve for y, we're going to subtract 4x on both sides. And that will leave us with y equals 5 minus 4x. So I'll circle that to remind us that that is the equation we will be plugging in to the other equation. Now keep track of the equation that you originally solved for y with. That was the first equation. And when you solved for y, you created an equivalent equation. So technically, these two equations are still the first equation. So when you're keeping track of where to plug this y back into, you're always going to want to plug it back into the second equation. So let's do that. If we plug this back into the second equation, remember that you will be substituting in for y this time. So our equation 2x minus 3, instead of being multiplied by y, we're going to replace y with 5 minus 4x. Keep in mind, you still have to finish off the equations. You still have to have the equal sign and the 13. Now, once you've substituted in for y, you have an equation in one variable. So from there, you're going to solve that equation. In this case, we're going to solve it for x. So if I'm going to solve for x, I will distribute the -3 to both terms. So that will leave me with 2x minus 15 plus 12x equals 13. From there, we want to see if we can combine like terms. So I'm going to look at 2x plus 12x. 2x plus 12x will give me 14x. Just going to rewrite that minus 15 equals 13. So from here, we're going to add 15 to both sides to isolate that 14x term. So here we will get 14x equals 28. To finally solve for x, we will divide both sides by 14. And we will get x equals 2. So I'll circle that answer to help me remember that I just found the x of my system. And once you know the value of one of the variables, you have the choice to plug that value into either equation to find the value of the other variable. Or since you've already solved the first equation for y, it might be easier to plug it back in for x, and there's less computation involved. So that's what I will do. So I will plug in x equals 2 to this y equation. So instead of x, we will write multiplied by 2. And from there, we'll compute. So y equals 5 minus 8. And simplifying 5 minus 8, we get y equals negative 3. So now we have the y value of our system. And if we're going to tie everything up in the end, we can say that our final solution, written as an ordered pair, is 2, negative 3. And that solves our system. Now I just want to address, sometimes we don't choose the easiest way to start off with at first, and that's okay, but I want to kind of demonstrate what would happen if instead of solving the first equation for y, you decided to solve for x instead. It's not too big of a deal, but you'll see what happens and what you might have to do to solve the equation. So if we had instead solved for x first, let me rewrite that. We have 4x plus y equals 5. And if we have decided to solve for x, we would have had to subtract the y on both sides. So that would leave us with 4x equals 5 minus y. And because the x still has a coefficient of 4, we would have to divide both sides or every term by 4 in order to solve the equation for x. So that would leave us with x equals 5/4 minus y over 4 would be 1/4 y. Now I'll circle that to help me remember that I just solved the first equation for x. Notice what happened when you chose to solve for a variable that has a coefficient other than 1 or negative 1. You kind of see how we're ending up with fractions in our result. And we've dealt with this before, but we just want to see if we can finish off the system. So let's see if we can do that. Keep in mind that you solve the first equation for x, which would mean you would have to plug in the x part into the second equation. So we'll do that. That would leave us with 2 times, instead of x, we're going to make sure that we plug in 5/4 minus 1/4 y. So it leaves us with 2x minus 3y equals 13. So we are left with an equation in one variable, but we just have fractions. So one of the things you can do, you might want to get rid of the parentheses first by using the distributive property. Could save us a little bit of extra writing. So 2 times 5/4, that's like saying 2 over 1 times 5 over 4. That's going to leave us with 10 over 4. Or if we reduce, that should leave us with 5/2. And 2 times negative 1/4 y, that will leave us with negative 2/4 y, or if we reduce, that will leave us with negative 1/2 y. We still have to subtract off 3y, and it's still equal to 13. Continuing to solve this equation, noticing that it has fractions, it might be nice to multiply both sides by the least common denominator, and in this case it would be 2. So we can do that. 2 times the left-hand side and 2 times the right-hand side. And if you distribute the 2 to all terms, what's going to happen, you'll have 2 times 5 halves will leave us with just a 5. 2 times negative 1/2 will leave us with just a negative 1/2 y. And 2 times negative 3y will leave us with a negative 6y. We'll still have equal. 13 times 2 is 26. So notice when you had fractions, we just revert back to our old techniques from the previous chapter of multiplying through by the LCD in order to clear the fractions from the denominator. So to follow through, we'll combine like terms. Negative y minus 6y is negative 7y. We still have that 5 in front, still equaling 26. And subtracting 5 from both sides, we will have negative 7y equals 21. And to finally solve for y, we'll divide both sides by negative 7. And that will leave us with y equals negative 3. To finally solve the system, we will take our y value of negative 3, and while you can plug it into either of the equations, sometimes it's faster to plug it into the equation that you solved for x for. So if we do that, we should get x equals 5/4 minus 1/4 times negative 3. And if we simplify just a little bit more, we get 5/4 plus 3/4. And noticing that they both have a common denominator of 4, that leaves us with adding across the numerator. 5 plus 3 gives us 8, keeping that denominator the same. And 8 over 4 is really just 2. So now we have our x value of the system. And if you remember what you got from the previous problem where you solved for y first instead, you'll notice that the solution is still the same. So the solution to the system is 2, negative 3, which matches our first idea from the previous problems. So again, just like to reiterate, when you're looking at which equation to start off with and which variable to solve for, it really doesn't matter what you start with, though your choice could cause you to have a little more complications in some of the computations and solving. So when in doubt, just follow through and hopefully you'll get the same answers, and you can always try a couple ways just to see and verify if you're correct.